So if you've been following this YouTube channel, you probably remember that I was posting developer videos about a game that I'd been working on called Project Universe. The idea behind Project Universe was that you would be a space pilot who would be traveling from system to system, docking at stations, buying commodities for low prices, and then selling them elsewhere for, hopefully, a profit. You'd have to deal with NPC interference, faction interactions, and interstellar events as you attempt to increase your wealth so you could upgrade your ship, hire crew, buy better modules, and eventually do things like own and operate your own space station or own and operate your own planet. That game was based heavily on my days playing Trade Wars, and I got pretty far with it for being someone who knows nothing about game development. But at some point it kind of fell by the wayside. I think it ended up being a little bit too ambitious technically in certain aspects. And that kind of threw me off. So I put it on ice. And this year, at the opening of 2017, I got the urge to revisit game development, but I didn't want to pick up where I left off. So this project, which currently does not have a code name, I've been calling it Trader Development, follows pretty much the same idea, that you will still be trading in interstellar commodities, but we're taking a different technological approach. It's going to be a lot less active participation and a lot more passive participation, a lot more keeping in line kind of with the idea of operating a financial empire. Now, that doesn't mean we're going to be essentially operating one massive spreadsheet, but we're not going to be flying around in a solar system scanning for asteroids or stations or anything like that. So I'm hoping that it's going to be easier, quote unquote, than the previous attempt. And considering I've only been working on this, I don't know, kind of maybe 2-3 months, I've already gotten a good amount of progress under my belt here. So this first video kind of wanted to introduce you to the beginning stages of this project, and this is going to be really kind of dry because I'm not going to throw too many graphics up. What I actually want to talk to you about is data. Data is really the underpinnings of pretty much any game. No matter what we're doing, whether we're shooting or running or jumping or building, everything is built on data. So the very first thing that I actually had to do was come up with data constructs. And a data construct in this case is essentially a definition of a particular object. If you are wielding a sword in a game, that sword has stats. It has numbers for, DPS and maybe some bonuses to it. But all of that is essentially data, and it's stored in a data construct. So, for example, our player object here, this is a work in progress. So this is a data construct which represents our player. So we have an ID, which technically isn't relevant as this is a single-player game, but it will help us differentiate between players and NPCs. The player name, their portrait, gender, and a list of faction reputations, as well as a data point of their current system ID. So all of this garbage here isn't really relevant, except to know that each one of these properties here stores the data that we assign to it during character creation, and then we'll save it to disk. So when you load a game, we'll read this off the disk, load it back into a construct here, a player construct, so that we can refer to this data whenever we're playing the game. The problem with video games is that there is both data that shouldn't change and data that needs to change. So I've modeled this by using two basically what I've been calling data buckets. The first is a database bucket. This is static data. The items in this bucket essentially are defined outside of the game They are saved and written to disk, and these are the data elements that don't change. So if you look here, we've got a commodity database, a ship database, station, and system databases. So, for example, the commodity database will hold the names and the pictures and the base price of a commodity object. We use this information in the game, and this is essentially immutable. Every time you run into, say, corn, it will have the same name, it will have the same portrait, and it will have the same base price. We define this and we set it up in this static database so that we can refer to it whenever we need to in the game. Now, the more difficult part is the dynamic or game state data. These are data elements that do change over the course of the game. We've already looked at the player info, but we'll also have elements such as player ship. So this represents information on the current ship that the player has, including the crew, the ship body type, how much cargo you can carry, and the modules that you've got. We also have, in this case, stellar body list, which we'll look at in the next video. That's how we're constructing our universe. And we have some meta items here. So whereas in the database we had the station and system databases, we do have information on a space station and also a solar system that does need to change over time, because we can't update this static information with data that changes over time. We're kind of shadowing it with these meta objects. And these items actually have the data that's modified. So in the case of a station, we have things like the commodity inventory, which essentially has references back to each commodity item and a quantity that's currently stocked at a particular station. So these two buckets essentially have to be loaded and saved. Now, the database object, the static objects, don't get saved during the course of the game. This is created outside of this game using a utility that I wrote, so I can manage this information. If there was ever a patch because the stats on a particular item needed to change, it would be this file, essentially, that gets updated. The dynamic game state information, however, this is what gets saved and loaded when you choose load and save from the game menu. And all of that is handled by this massive script called the data controller. In Unity, there's the concept of a controller. In this case here we have a main menu controller, which is kind of the very top level object that deals with menus. This this top level main menu controller has a script called main menu controller. And this script right here is essentially what controls everything that goes on with any objects that live below this main menu controller in the hierarchy. Now that's very specific for this particular case, but all you have to know is that a controller in practice is something that kind of lives above and beyond all of the stuff you see on the screen usually, and it does things like run simulation and handles core logic that's not specific to an instance of an item that you see on the screen. In this case, this data controller lives even further outside by being made available throughout the entire game. And the purpose of this data controller is to handle the loading and the saving and the setup of the data when you start a new game or when you load or save a game. We have some file path information that we use to standardize the saving and loading locations. We have file operations. These are very specific file operations, such as saving the game, loading the saved game list, loading a saved game, and then loading the main static data. So these 4 methods right here deal with the loading and the saving of all of the data in the game. We also have these are some generic methods here which allow us to essentially write once and use over and over again, but that's language specific. But we also have then some very specific applications down here. So when we create a new game, right now what we're doing for testing is we are setting up the universe in a process called the Big Bang, and then we determine to make sure that our static data has been loaded, and we create essentially a placeholder for the player object. And once we do this, we'd essentially kick the user over to allow them to create their character, and we'd update all of this information. This information is essentially stored in the game state data bucket. Now, we did look at this instance over here called game state object, but this on its own is kind of useless. What we do is we make a reference to it up here at the top level of data controller. What all of this means is that our databases, our static data and our game state data, are going to be available to us everywhere in the game by calling data controller. This is incredibly powerful. It also kind of flies in the face of the way Unity is supposed to work, kind of. But the idea being that all of our data, whether it's static data, game state data, or whether it is simulation data, happens kind of outside of the operation of what you see on the screen. And whenever items on the screen need to know either about themselves or maybe even about other elements in the game, they can get that information from the database through data controller. And that turns out to be really, really powerful because it separates the operation of the game from what you see in the game. I could essentially write the entire game in code here using this method, all of these methods referring to data controller to test universe generation, player movement, and more importantly, the simulation process, the act of buying and selling and having commodity price change as a result, or the event system, so that if there's a civil war in a particular star system, it may have an effect on prices or even access to the system. All of that can be written without even ever opening Unity, without even ever dealing with Unity itself. Unity really only comes into the picture when I want to see the results of that simulation, and when I have to start dealing with visualization, user interface, and so on and so forth. So this is essentially the whole point of the data and the role that it plays in this particular game. I don't really know how professional game developers do it. I'm sure it's probably different in every situation, but for this particular game, which does not really rely on millisecond response times, being able to look up data from a central database actually has a lot more advantages that we're not getting into here, and we won't get into until we can actually see them in motion. But it's working very well. It's working quickly, and it's going to also allow a lot of, maybe not as much flexibility as I would have if I were working with Unity the way Unity was intended to be worked with, or the way that you would see in games that do require up to the millisecond updates, more action-oriented games. But what this does is it allows for maintenance outside of the game itself, and also allows the game to operate kind of behind the scenes a little easier. So in the next video, we're going to look at the universe creation and simulation, which will include some some work done in Unity, because I do have a little bit of it working. Thanks for watching, and stay tuned for the next video.